chapter 9 is called differentiation. So what is differentiation? Like what we have learned from year 11, differentiation is finding the gradient of a graph, which is like you have fx, you want to find f dash x. But before we go to find f dash x, let's think about some general things related to finding the differentiation. So the first thing we want to talk about is limits and continuity. So we have actually a couple of things to talk about. The first thing we want to talk about is defined. And then we want to talk about limit. And then we want to talk about continuity. And we want to talk about differentiability. Okay, so there are 4 things we can talk about according to one point. Okay, I give you a function or I give you a relation. I want to talk about a single point on this graph. 4 things I can talk about. Whether it's defined, what is the limit, whether it's continuity, whether it's like continuous, whether it's differentiable. Okay, so 4 things we can talk about according to one point on the graph. Okay, so today we talk about limits and continuity basically, and also we talk about defined. Defined is just one sentence. So what is defined? Defined is we say fa is defined when x equals to a, fx has a corresponding y value. Okay, which means there is a point at x equals to a. You can find out a y value when you substitute x equals to a. In other words, to be defined, you just need that the function is not an open circle at that point. Okay? It's not an open circle at that point. It needs to be a closed circle. When you substitute a particular x value, you can find out that value. So that's defined. And we consider the limits of a function fx to be valued that fx approaches as x approaches a given value. So what that means? Okay, so we said lim x approaching to a fx equals to p means that when my x value approaching to that x, okay, that particular a value, and the y value approaching to a p value. Okay, let me show you this case on the diagram. Okay, we have a graph like this. And I have a point A, and this p value, this is a p, okay, where x equals to a, y equals to p. So think about when my x is approaching, like approaching not means x equals to a, it means get closer and closer to a. And you can think about your y value. When it's getting closer to a, your y value, think about that. The nearer to a value, the more closer you have approaching to this p value. Okay, so if you go from this side, okay, approaching to that, for example, you have 0.01, and you then decrease another 0.01, it's approaching to this height. If you go from that side, okay, okay, up to here, and then you go closer to that level. As you get close to the point A, get closer to the point A. From both ends, your y value is all approaching to this p value. So that means the limit. Okay, that means the limit. It is important to understand that it is possible to get as close as desired to p as x approaches to a. Okay, you can have like 0.001 difference or 0.00001 difference, and the y value will approaching to that p value. So note, for a function fx, a limit exists. Okay, that's to test about whether it exists or not. A limit exists at x equals to a if left hand side and right hand side limit exist and equal. Okay, left hand side and right hand side limit to be exist is number 1 and equal is number 2. Okay, you need to have limit on both ends. Both sides, okay, both sides. And at the same time, you need them to be equal to each other. Otherwise, the limit doesn't exist. We can show a lot of counterexamples later in the exercise. But this is the definition. If I'm asking you whether it is exist or not, what you need to answer me is, like, you have left-hand side limit, you have right-hand side limit, the limit from both sides equals, and then which means it is exist. Okay, you need to explain two things. Okay, fx may or may not be defined at A. So which means if you have an open circle at x equals to A, that doesn't mean your limit doesn't exist. Okay, it's still possible to exist when that point is not defined. Which, in other words, it means limit and defined has no connection between each other. Okay, it can be limit exist and defined exist, or like they both not exist, or one exists, one not exist. All the counter examples is below here. Okay, I'll show examples. The concept of limit as something we are approaching, but we may not necessarily reach perfection is a limit. We call all head towards, but never reaches. X approaching to A doesn't mean X on A already. It means get closer and closer to A. You still have a little bit difference between the actual value you get and the A value. So let's think about this. Decide whether F0 exists or and fx approaching to 0, fx exists or not. So it tests about two things. Whether it's defined at x equals to 0 and whether the limit exists at x equals to 0. Okay, first of all, let's think about F0. So F0 is here. It's not an open circle, so defined definitely, yes, it is defined. Okay, it is defined. And think about the limit. Limit is your test left-hand side limit and right-hand side limit. Okay, so if it's left-hand side limit, your graph go that way, all the way towards to this point. Okay, so all the way towards 1. And then if you go from right-hand side, think about a point moving on the right-hand side and getting closer and closer to 0. So it's still that point. So left-hand side, right-hand side limit all equals to 1. So what you should write is lim x approaching to 0 from the negative side, fx equals to the lim x approaching to 0 from the positive side, fx. So the limit does exist. That all equals to 1. Okay, limit from the left hand side and limit from the right hand side all gives you 1, which means the limit does exist, and you will say lim x approaching to 0, no positive or negative, fx equals to 1. Okay, so you just think about there's a point moving from the left hand side and to reaching, like get closer and closer to the value x equals to 0, and to see which point is actually approaching to. And you have another moving point from your right hand side of the graph and moving all the way towards 0, and which point is get closer to. Compare the 2 points, get like approaching from both ends. If that is the same point, then the limit does exist. If different points, the limit does not exist. Okay, so that's the easy case. It's a continuous graph, like it's just a straight line, which is easy. Let's have a look at the second one. Okay, do you think it is defined at x equals to 0? Is it defined? No, infinity is not something you got a value, okay, it's undefined. So it's not defined at that point. Okay, it's not defined at that point. Okay, think about the limit. Do you think the limit exists? Do you think the limit exists? No. Why limit not exist? Which one is not satisfied? Not satisfied 1 or not satisfied 2? Okay. I need both and the limit exists. But think about you have a moving point. Okay, moving along this curve and all the way towards 0. But what you get is infinity. Okay, it's infinity. So limit x approaching to 0 from left hand side fx, it just gives you something approaching to 0. You don't have equal sign there because infinity doesn't mean you can get. Okay, you can't get infinity. So it's approaching to infinity, which means you don't have a limit. The limit does not exist. So it actually failed number 1. Okay, it failed at the beginning. Okay, failed at beginning, so you don't have the limit. So the limit does not exist either. Okay, so for the first two examples, the define and limit both exist or not exist. Okay, both exist or not exist. Let's think about the next one. Okay, do you think this one is defined? Defined or not? Everyone think defined or not? Y sub x equals to 0, will there be a value? Yes. Even though this one is an open circle, but this one is a closed circle, it's hybrid function. The hybrid function will only take like one zeros, not both zeros. You can't have two closed circles there. So, which is actually very correct. One open circle, one closed circle. And when x equals to 0, I will take the closed circle. So my f0 actually equals to, what's that point? It's 1. Okay, negative 1. My f0 equals to negative 1. My f0 not equals to 0. Okay, it's not taking the 0, 0 open circle 1, it takes the closed circle 1. So it actually defined, because when x equals to 0, y equals to negative 1. If both end is the open circle, which means it doesn't exist. Okay, but one closed, one open, which means exists. Okay, let's think about the limit. Let's think about whether the limit exists. From your knowledge learning from last year, do you think it exists or not, the limit? No. Okay, the limit doesn't exist. But why it doesn't exist? Let's moving from the left-hand side, okay, very left, and going towards 0, okay, going towards 0. I need to travel to the right, okay. I have a moving point here. Okay, I'm moving, going up along the curve, go to the right. Until I reach 0, okay, 0 is this line, until I reach that line. So I will get closer and closer to this point. Okay, right, I will get closer and closer to that point.
The lines timeline calculated for 50%.
Okay, get closer and closer and closer to that point. So if I go from the left-hand side, the limit when x approaching to 0 from the left of fx, that will equals to minus 1. Because the y value is negative 1 for that point I'm approaching to. So go from the left, I will approaching to that closed circle, that point. Okay, if I go for the left, go for the red, okay, from the positive side, and go downwards towards 0. Okay, towards 0, here is 0, okay, here is 0. So I will stop before that line, okay, I'll stop before that line. So get closer, closer. So which point is approaching to? It's approaching to that open circle, okay, it's sliding down until 0, it's actually approaching to this point. Okay, at what level of that point? That point is at level 0. Okay, so I'm approaching to 0 from, if I go from the right hand side. So the lim x approaching to 0 from the positive side of fx equals to 0. Okay, if I go to the left, going up, I'm approaching to negative 1. Sliding down from the right, I will approaching to 0. So the limit of x approaching to 0 from the left is not equivalent to the lim x approaching to 0 from the right of fx, which means does not exist. Okay, which means the limit does not exist for x equals to for x approaching to 0. Because even approaching to 0, I approaching to two different values. I don't know which one I should take. So the limit does not exist. Okay, the limit does not exist. Okay, let's have a look at this diagram. Let's have a look at this one. Do you think it's defined for this one? at x equals to 0. Open circle there at x equals to 0. Can you see an open circle there? Like, it's not defined at x equals to 0. But let's think about whether limit exists or not. Okay, m's going from the left hand side, so I will go up. I want to go towards 0. So I will get approaching and approaching to that open circle. Okay, which is at level 1. Okay, level 1. If I go from the right, I need to slide down to approaching to 0. So I will approach to the same point. Okay, it's pointing to the same point. Okay, it's pointing the same point, which means my limit does exist. And the limit of x approaching to 0 for fx equals to 1. Even though f0 is not defined, I can still approaching to 1. Okay, I can still approaching to 1. Okay, those 4 examples show you all the different cases between defined and limit, and it can show you that there's no relations between defined or limit. Okay, it can be defined not having the limit, or it can be not defined by having the limit, or can both define limit and limit both not defined for limit and that point. So it's all good. Okay, so 4 different examples show you the 4 different cases. Okay, so that's how we think about whether a point is defined and whether the limit does exist or not. Okay, so in general, the limit x approaching to a will exist if from left hand side approaching to a and right hand side approaching to a equals to each other, which I have 2 cases. The first case is x equals to a is continuous at that point. Okay, it's continuous at that point. And the second thing is, it is not continuous at that point, which I have a holder, but like it seems like it's just the only holder and it's still connecting to each other. So I have 2 cases. Okay, I have 2 cases. It can be defined or not defined. That's the point I want to make. Okay, for limit equals to approaching to a does not exist. Okay, does not exist means the both and limit not be the same or like not equals to each other. Okay, so 2 cases I can have. The first case is like I have a jump here, vertical jump here. Okay, there's a vertical jump. I don't have like that values. Also, I can have a horizontal jump. If it's a horizontal jump, can you see like I have no values in between this black line, which means there's a horizontal jump. But anyway, like there's a jump, I can't find the limit. Okay, if there's a jump, vertical or horizontal, I don't have the limit. I don't have the limit. Any questions so far? No? Okay, the next thing is how we can evaluate the limit. Okay, how we can evaluate limit x approaching to a. So I will say follow this chart. So how to evaluate lim x approach to a fx? First thing is the denominator of fx is a constant or there's no denominator. So first I just think about whether the denominator, we have a denominator or not. Whether the denominator contains x. Okay, so if the denominator is a constant or absolutely no denominator, what I can do is I just substitute a into the function and that is the limit. Okay, that is your limit. And because you can see that, right, when we find the limit is basically the values like you have for that point. It's basically that value. Or like for some case, which is the open circle, we'll talk about that later in another case. But basically it's the y value at that point. So I will substitute that. Why I can substitute that if there's no denominator? If there's no denominator means the function is continuous at that point. Because there's no denominator means there's nothing wrong with x equals to a, which means at x equals to a it's continuous and there's no jump at the point a, so I can directly substitute that in. if that's a hybrid function, we'll talk about that in other case. But like for a single function fx, we'll use this method. Okay, how about if there is a denominator carries x terms? The first thing is to test. I will substitute x equals to a under the denominator, okay, into the denominator, and to see whether the denominator equals to 0 or not. If the denominator is not equals to 0 when x equals to a, I can still do the same thing, substitute a in and work out what is fa and directly have that. So basically those two are the same case, okay? Those two are the same case, which means there's nothing wrong when I substitute x equals to a, because the denominator is not 0, I can directly substitute that in and find what is fa. So when the problem occurs is when the denominator equals to 0 when you substitute a. You can think about that. If you substitute x equals to a and that you get a 0 denominator, which means you can't calculate, right? You can't calculate something over a. So you need to do something to make the denominator not become 0 first. Okay, to not become 0 first. So what you can do is expand, factorize, and simplify, cancel something, and make the denominator not become 0. I'll show you an example here. So all the things I want to do is I can substitute fa. Okay, I can substitute a into the function, and which allow me to do the calculation, which means my denominator not equal to 0. That's my only requirement. Okay, so all the things I want to do is here. To change the equation and make the a can be substituted. Okay, make the a can be substituted. So before we evaluate that, there's some theorem on limits, which I think is really useless theorems. I'm not going to practice on that. I'll just tell you what are they. So when you, the first one is important. The first one is limit x approaching to a for fx equals to c if the function is a constant function, which means if I have lim x approaching to 1 for 3, that still equals to 3 because there's no change between compared to x, okay? Y is not changing when x is changed. So always have 3. It's a horizontal line and the limit everywhere will be 3. Okay, everywhere will be 3. So doesn't really change with the x changes. So we have limit for a constant, the limit will still be the constant itself. Again, for number 2, 3, 4, which means if you add two function, you times two function, you divide two function, it means like you limit them and sum the limit together, or you find the limit separately and you times the limit together, or you find the limit separately and you divide the limit together. Okay, that's the only thing they can talk about here. But we don't really use that. It's very time consuming and it's not really helpful for you to do things. You just need to remember, okay, there's something for limit theorem. If you add two functions, it means and find the limit, which means find the limit separately and add the limit together, or times limit or divide limit together. Okay, that's the only thing to talk about in those three theorems. Okay, let's evaluate the following. Okay, that's the most important thing I want to talk about. So evaluate the following. So how we can evaluate the following? 10 is not changing when the x is changing, so that is just 10. Okay, it doesn't matter what x really approaching to, the limit to a constant is still that constant itself. So that is just 0. Okay, part B. Do we have denominator? No denominator, everything is good. Sub 0 in directly. Okay, sub 0 in directly. So 2 times 5, which gives me 10. Yes, 2 times 5 gives me 10. So still 10. Okay, still 10. For the next one, do we have denominator carry x term? Yes. If we substitute the limit of -2 into the function, is there anything wrong? Is that denominator 0? No. So substitute directly. So 5 minus 7 times -2 over -2 minus 2. That gives me 9 minus 19 over 4. Is that 19? Yes, minus 19 over 4. So that is the limit. Directly substitute. If I can substitute, directly substitute. Okay, next one. Can we directly substitute for this one? No. The denominator will be 0. If you put -3 into the denominator will be 0. So which means I cannot directly substitute. I need to do something to this function first. Okay, so what I can do, if I want to adjust this function, I need to keep the lim x approaching to -3 there, okay? Because I'm not substitute that yet. I'm just changing that function. So I need to keep that lim here, okay? And what I want to do is simplify that function. Can you see there's both x plus 3 and x plus 3 on top and bottom? I can cancel them. You have 2x plus 3 on the top and 1 at the bottom. So what you have is 2 on 5 bracket x plus 3. Okay, that is what I will have. And now we can substitute, then the limit will go. I will substitute -3 in, that it gives me a 0. Okay, that gives me a 0. Okay, so tell me what is this function? Like what type of this function? What is it? Like name? Linear? Linear? You have linear, right? Okay, so let's sketch this linear. Let's sketch this linear. Okay, so if that one is a linear, then this one must be a linear as well, right? That comes from that. They are equivalent. So this one is a linear. It will be the same as you sketch the top thing. Okay, sketch the linear will be the same as you sketch the top one. Okay, is there any problem? Like, I'll sketch this linear first and tell me is there any problem here. Okay, that is the linear. Okay, that is the linear, so that is 0, 6 on 5, and that is -3 and 0. Do you think like we need to change anything, or like that is already good enough? Like why we write this, we not write this? What's the difference between the top one and the bottom one? Yes, this comes from this top. But is there anything you remember from last year? Yes, good. Okay, so from the top function, you have restrictions on your domain. Okay, remember the implied domain? When you look at this function, you think about, okay, denominator can't be 0. X can't be 3, -3. Okay, that's the thing you work out from the top. Okay, it doesn't change when you cancel the x plus 3. The limit exists, the restriction exists at the very beginning. So what you can find for this function, is x cannot be -3. Okay, what you work out from that function is x cannot be -3. When you know that and you start to cancel them from top and bottom, you simplify it. But x still can't equals to -3. So what it means by that is you will have an open circle here. It's not a perfect linear, you will have an open circle at x equals to -3. Okay, so that's the difference between the top one and is like a linear. Okay, it's missing one point, missing the x equals to 0, missing that one. X equals to -3, missing that point. But like the limit still exists, it still equals to -3. Okay, so the limit still exists, still equals to 0. Okay, approaching to -3, it still be 0. Okay, for the next one, I can't directly substitute. Did you realize that? I can't directly substitute, so I need to do something. But before we substitute, the lim x approaching to 2 is still there. Okay, always there still. So that gives me x minus 2 and x minus 3. Okay, to factorize the top and bottom. And you can cancel that, but I'm still not substitute x approaching to 2. So keep it there, cancel them, you will have x minus 3. Okay, we have x minus 3. So it's still a linear, x minus 3, but you will got an open circle at x equals to 2. Okay, we got an open circle at x equals to 2. Because from the very beginning function, it gives you the domain restrictions, x cannot be 2. So after you simplify a linear function, but at x equals to 2, that still be an open circle. Okay, still be an open circle. And now you can substitute 2. So 2 minus 3 will equals to minus 1. So you will have 0 minus 3 0. You will have this, but at x equals to 2, you will have a point here. 2 is here, so you have an open circle here. Okay, that open circle is 2, negative 1. You have closed circle here, that is 3, 0, and that's 0, negative 3. But that point is the open circle. However, the limit still exists, is negative 1. Okay, for the next one. I still can't substitute 0 into it because the denominator is 0. So what I can do is factorize, expanding or simplify. So I'll make x approaching to 0. What I will have for the top will be 3 plus 2x plus 3 and 3 plus 2x minus 3. Okay, a squared minus b squared. A plus b and a minus b over 2x. Then lim x approach to 0. I have 2x plus 6 times 2x over 2x. And the 2x and 2x can be cancelled from each other. You will have 2x plus 6. Now become a linear again. Okay, become a linear again. And I will put 0 in. You will have 6. Okay, you have 6. Okay, I'll talk about the next tomorrow.